All right, this is the last page, page 8 of 11, 6, 7 section. It's just to, Alex, what if they give you Z and look for P? What if they give you P and look for Z? What if they give you Z and look for X? What if they give you X and look for P? So these are the three things we have to be able to go back and forth on no matter what they ask. Okay, you need to be able to turn an X into a Z. That's this formula, right? A Z into an X, that's that formula, right? Mean, Z-score, standard deviation. And then to turn an area back into a P, you have to find them in the table. Okay. So let's kind of see what we need for this one. Where's the information on this? I'm looking for one and it seems to be missing. Well, all the information is here. We must be talking about, I'm sorry. It was on the last page, number 1. Let me get that back out. I was like, where's the rest of this problem? So example number, on page 7, example number 9 started out with this examination series on women's ages from 20 to 55 with a blood pressure measurement of. Okay. And we looked up that one. That was number 1. Number 2 says, what percentage of women have a pulse rate below 60 and above 95? So we're keeping all the same numbers from the one before. So let me put these numbers back on this scale here. So remember the average was 45 for that. And then we're going to add 12.2 standard deviation. I'll try to be neat about this. 9, 8, 9, and then 111.1. And then we're going to subtract standard deviations. That is a 37.9. Okay, so that was the -3 standard deviations 2. These are the Z-scores I'm putting in now, corresponding Z-scores that are equivalent to my standard deviations. Oops. 2, 3. And this one is the same. So these are my Z's, these are my X's. All right, so for number 2, we're looking for percentage of women that have a pulse below 60. So that means they're telling us right here they have a blood pressure pulse. So below 60 is the same as to the left of 60, but I can't look up 60 in the chart. I need a Z-score for that 60. So this right there turns, X's into Z-scores. Okay, so you can look them up. This one here turns Z-scores into data values for X's. Okay, so we need to do we need to go the value of the X. Can you see that? Sorry, the lighting is kind of weird too. There we go. That's a little better. So this formula turns z-scores into x. This formula turns x's into z-scores. Okay, so all they gave us here was a score of 60. So we want to put that in as x, subtract our mean, which was 74.5, and divided by standard deviation, which is 12.2. Okay, if you do that math correctly, you're going to get a z-score of negative 1.19. Remember, we want to round it to 2 decimals no matter what for z-score. Okay, so that means z equals negative 1.19, and that makes sense with our picture. Okay. So then it says what percent of women. So basically, they would now want to know this. Okay, so I'm going to go to my. So this, let's see, put this in steps. That was A. And then B would be look up negative 1.19 to the left to find P. So we're looking using negative scores, negative 1.9. Oops. And it doesn't matter if you use the right. I need my negative 119. Negative 119 is 1170. All right, so here now it's 117. So that if they want a percent though, so this is 117%. Okay, for number 2. I couldn't go straight there. I had to go from X to Z to P, our area. Okay. All right, and then above 95 beats per minute. Above 95 is, I don't know, in here somewhere. So that's to the right of whatever this Z is down here. So we need minus the mean over the standard deviation. Do the math right and round to 2 places. You're going to get 1.68 positive. 1.68, and then we need to look up on positive Z table. Now remember, it's to the right, not the left, so it's 1 minus whatever they say on the table. So 1.68 on the positive, 1.68 is 9535. All right, and 1 minus 0.9535 is 0.0465. Percent-wise, 4 point, let's go 4.7%. So U.S. women have a pulse rate below 60 is only 11.7%. Above a 95 is only 4.7% of women, since they're normally distributed. What's this one over here? Pulse rate between 65 or 55 and 70. So let's put this back 45, 70, and what did they say? 55. So when they put these are our standard deviations. Here's 50.1. So 55 is kind of in here somewhere. I don't know where. And then 70 is kind of in here somewhere. I don't know where. And they're looking for this percent. Right? But I also don't know these. So I can't go to the left and to the left. So it says this was an X of 55. This was an X of 70. So an X of 55, no, that's what I wanted, would be from their X bar, the average, plus the Z score, which I don't know yet. Wait a minute. Wait. This is my last video. I'm on my 8th page. I'm getting a little crazy here. X to get a Z. I'm awake. 55 minus 74.5 over 12.2 is going to give me negative 1.59. Negative 1.59 for that one. And then Z with a 70 minus 74.5. Write this one here. 12.2. You're going to get a Z. I expect still a negative number because remember, zero's here. So still a negative number. Put this in the calculator and I get a negative 0.37 for here. That makes sense. Real close to zero, 70, right? That makes sense. All right, now I have to look up in the table. To the left. All right, so this one over, and then subtract them. So this one on the negative, .37. 0.37 is 3,557. So from here this way, 0.3557. All right, and then from here this way, negative 159 is 0.0559. 0.0, wait, yeah, 559. All right, so this is from here to here. This is all the way over, so it's this minus 0.0559 is going to be 0.2998. So if you're making a percent to 4 decimals, 2998. If you're making it to 3, this is the same as 0.3 because all these rounded up move over. So this is 30% if you're an Alex for that one there. Okay. Very last one. The doctor is worried about the pulse rate. So we're still here of patients that are below 5% and above 5%. So these are worrisome pulses. So they're looking for this. 5%. 5%, move the decimal, 2 places, 5% here. and 5% here. Let's see, 5% below and 5% above. Okay, and they didn't split the 5 between the two. All right, so I need the z-scores for this p. So on the negative, and whatever they are, they're the same. If there's exactly 5% here and 5% here, then I could find the 1 minus for this one. This is the easiest one here. This would be to the left of this would be 0.5. So that's a negative. Point 0.05. 0.05 is in the middle. That's one of those ones, 1.645. So you might as well just go negative 1.65. So that means this is positive 1.65. Okay, negative, positive. All right, so then to find this value, we need to take your x bar, which is 74.5, and add it to a negative 1.645 or 5. Like I said, if you get close, let me know. I'll go back and give you credit for it. I tend to round up to 2. I don't like using, I mean, if the rule is that z should be 2, then you round up. Don't forget to multiply before you add, and you should get here, let me double check that. Forgot my negative sign. Gosh darn it. 7.45. Almost done. Plus parenthesis negative 1.65 times 12.2. 54.37. Depending on what number you use here, you're going to get a range of 92 to 54.37. So anywhere in here I would take. It just depends on the method you're using. I used a 5. It's that. That's the most it could be. I mean, this rounds to a 5, so that rounds to a 4. So, you know, it's in that area. They would be concerned about. And then this one would be 74.5 plus 1.65, 12.2. This is going to come out to 94.569. The range of answers acceptable for this one. Sometimes they will have a range built into the ALEKS answers, so they will take anything kind of in this range for that answer. That's a pretty big range. Mine's in the middle there somewhere. So basically, they're concerned about anybody over 94.5. So this is 94.5 is my final answer here. And this and below, this and above are the ones that they're concerned about. Okay.